Let's look at some examples of where we use SOH CAH TOA to find angles. The key thing is that SOH CAH TOA can only be used for right angled triangles and that it doesn't work for non-right angled triangles. If we start off by looking at this triangle, we've got a right angled triangle with two side lengths and a missing angle that we're trying to work out. So the first thing we do is we label each of the sides in relation to the missing angle that we have. So the opposite side is the 5 here, we can label that as O. The hypotenuse is the side that's opposite the right angle, so we can label this side here 13 as H, and the side that's left over is the adjacent side, which we label as A. So we see that we've got the opposite side and the hypotenuse, and so looking at our acronyms, we need to find an acronym that has O and H in it, and we see that SO is the one that has O and H in it. So we have the following equation: sine x equals to the opposite side 5 over the hypotenuse 13. Taking sine inverse of both sides, we get that x equals to sine inverse of 5 over 13. And putting this on a calculator, we find that x equals to 22.6 degrees to 1 decimal place. If we look at this triangle, we've got a right angled triangle and we've got two side lengths and a missing angle that we're trying to work out. So the first step is again to label each of the sides in relation to the missing angle that we're looking at. So the opposite side is this side here, we label it as O. The hypotenuse is the side opposite the right angle, which is 13 here, so we can label that as H. And then the adjacent is the side that's left over, so in this case the 12. We see that we've got the adjacent side and the hypotenuse, and so looking at our acronyms, we find that CAH is the acronym that has A and H in it, and so we can use this equation to work out the value of x. So we have that cos x equals to the adjacent side 12 over the hypotenuse 13, and so taking cos inverse of both sides, we find that x equals to cos inverse of 12 over 13, which if we put on a calculator to 1 decimal place, we get 22.6 degrees. Finally, if we had the following triangle with these two sides now and the missing angle x, then again we would start off by labeling each of the sides in terms of the opposite, adjacent and hypotenuse. So the opposite is the 5 here, we label that as O. The hypotenuse is the side opposite the right angle, we label that as H, and the adjacent is the side that's left over. So in this case we see that we've got the opposite side and the adjacent, and so looking at our acronyms, we have O and A in TOA, and so we have the following equation: tan x equals to the opposite side, which is 5, over the adjacent, which is 12. Now taking tan inverse of both sides, we have x equals to tan inverse of 5 over 12, and if we put this on a calculator, we find that x equals to 22.6 degrees to 1 decimal place. We've looked at different scenarios where we would use SOH CAH TOA.